We can also find inverses by composition. If we take f of g, which remember we could write like this as well, f of g. If f of g of x is exactly the same thing as g f of x, or I mean, if that gives you x, or if g of f of x gives you x, then it is an inverse. Okay? So that's another way of determining inverses. Let's see. So it says show that these two functions are inverse functions. So here's what we could do. I could take f of g. So if I did f of g, then what I would be doing is I'm plugging g inside of f. So I'll take my f, but instead of that x, I'm going to replace that x with g. Okay, so there's my equation. Now as I start to solve this, PEMDAS says I start with the parentheses. I cannot do anything here. You could say, oh, distribute that, but I'm actually, since these are multiplying, it doesn't matter in the order of multiplication. I'm going to first distribute that to there. Now look what we get if we do that first. 2 times 3 is 6, and 3 times 2 is 6. So we actually have 6 over 6 times x minus 2, and then again the plus 2 remains out there. Now 6 over 6 is the same thing just as 1, and so now I have x minus 2 plus 2, and those cancel, and guess what I'm left with? X. Because I'm left with x, these must be inverse functions. And the reason I knew that is because we did f of g and got x. If you ever take the composition of two functions and you end up with x, they are inverses. Let's look at these pictures. And we can see here's this right here is f of x. They're not labeled, so I'll label them. That's f of x. This function here is g of x. And notice they're reflections on the line y equals x. So since they reflect each other, they are inverses. So graphically, you can always check your answers. All right. Here's one for you to try. See that these, in fact, are inverses. Check the work and see which one's correct.